is based on the principle that hot air occupies greater volume. Right? Gases, they occupy the entire volume. I mean, volume increases. If you bring the temperature down, the volume will also. Volume at 0 degrees Celsius, volume of a gas, will it become 0? The curves which we plot at constant temperature are called isotherms. So 1 mole of any gas contains how many molecules? 6.03 into 10 raised to power 23. That is Avogadro's number. So those. Now we have some numerical problems, right? I've solved. Don't click. Let me discuss this problem with them. Now, calculate the volume of a sample of gas which is at this much pressure, 5.575 atmosphere, if it occupies 5.14 liter at this. So, I will tell you how to attempt a question also. Suppose there is a numerical, right? Just in this case, you have a numerical. Can you solve this numerical on your own? Yeah. It is simple based on the expression of your Boyles law, right? So, before you attempt any question, specifically a numerical, first enlist what is given to you, right? So, in this particular numerical, what is given to you? You have been given the pressure and volume in one state and pressure in one case. It means you have been given P1, right? P1 is given to you. P2 is also given to you, right? V1 is not given to you. V2 is given to you, right? So you can use the simple relation which is P1 V1 is equals to P2 V2. Okay. कर दीजिए नेक्स्ट आ गया आंसर भी है इसमें नेक्स्ट right? So you can calculate this thing using this simple relation, and you can also see when you solve this numerical, try to analyze that the concept that you have learned, whether the answer you are getting, it is satisfying that statement or not. So you can see if your pressure is less compared to 5.75, pressure is less. If pressure is less, then volume is more, right? And in this case, if pressure is more, volume is less. So answer makes a sense. It means while calculating or while attempting any numerical, if you get some abrupt answer, then you can very well see that there is some problem in the calculations that you have made, right? So you should always relate the two things. Next. Again, we have a question, this thing. If a sea diver, I forgot to discuss this example also, sea divers, you know, that they go to deep sea, deep waters, right? So there also you can apply this law. What happens? How much is the pressure? Pressure, is it, inside the water. What is the pressure? It is greater than the atmospheric pressure or it is higher? It is greater than, right? You know that you have a barometric formula also. If you go higher in the height, I mean, as per your height, if you go higher, then pressure decreases. And if you go deep in the sea, the pressure is increases, right? So sea divers, when they go in deep waters, there is a lot of pressure, right? when pressure is very high, right? So then what happens? That the volume, right? Because you intake what? Oxygen, right? So oxygen that you intake, it is a gas, right? Because it is a gas, it can occupy the entire space which is being available to it, right? So the moment pressure becomes higher, volume has to decrease, right? So the amount of oxygen which is dissolved in your lungs is lesser in that case, right? So sorry, more. Now what happens that when sea divers, they comes on the surface, you can see this problem also, it is directly related. If a sea diver takes a breath at the surface, filling his lungs with this much of air, right? The volume is given to you. What, sorry, yes, volume. What volume of the air in his lungs occupies when he dives into the depth where the pressure is this much? So you know that at surface, the pressure is 1 atmosphere, right? The pressure is given to you. Again, you have to use the simple Boyle's law statement. Pressure at the surface is 1 atmosphere, volume is given 5.82 liters, and P2, pressure inside the sea, is given to you, and you have to calculate the volume of oxygen or the volume of air, right? Now then you can use, it is slightly displaced, that thing, V2 is equals to P1 V1 upon P2, and then you can see that it is the answer which you are getting, it is 3.03 liter, right? So you always relate this thing that at higher pressure volume should be smaller, which you are getting, right? So volume of the air which is dissolved, it is lesser. It is because of this reason that sea divers, they carry oxygen cylinder, right? They carry oxygen cylinder because there is less of oxygen in their lungs and they would then have difficulty to breathe, right? Next, the next law, after discussing the Boyle's law, I hope it is clear to you, the Boyle's law. Then we have Charles' law. I told you that all these variables, they are interrelated. You keep one constant and see the variation of the other two. Now here, there you kept what? You kept temperature constant in the Boyle's law. Here in the Charles' law, you have to keep pressure constant. So keep the pressure constant and then you see the variation of volume with temperature. So volume here, Charles, he observed that volume is directly proportional to temperature. If you heat the sample, gases, they occupy the entire volume. I mean, volume increases. If you bring the temperature down, the volume will also decrease, right? It is directly proportional, and you can see the variation also since the two are directly proportional to each other. But you have to keep one thing in mind. Look at the statement very carefully. I've written that the at constant pressure, the volume is directly proportional to the absolute temperature of the gas. What do we mean by the absolute temperature? I'll explain you next. I mean, just for in the next slide. But before that, you see that when volume is directly proportional to temperature, so of course, here also, if you remove the proportionality sign and you put a constant, you will get that V1 upon T1 will be, instead of PV, like you got in case of Boyle's law, you're getting here the ratio of volume and temperature at a constant pressure will always remain a constant, right? So V1 upon T1 is equals to V2 upon T2 is equals to V3 upon T3, and so on, will be equal to a constant, right? Now, next, have you ever heard about the hot air balloon technology? This is a very good example of this law. What is the principle of the hot air balloon? You ever heard about that? Yes. Blow fire under a balloon and the air gets warmer and the gases and they also have some kind of plates attached to the balloon. As they move That is also there. Yeah, she explained it well. Just to elaborate, it is the concept of Charles' law that volume is directly proportional to temperature. It is being used in, you know, that man is very ambitious. Desires are always there. So desire to fly was always there. So it was the first instrument, just like this was invented much before the aeroplanes and all they came into roles. 1783, Charles, it was not Charles actually who designed this balloon, but there were two engineers, Robert brothers. They were called Nicholas and one more, I forgot the name. Robert brothers. They were there. They designed a balloon for Charles because Charles wanted to verify his law, right? So he wanted to experiment on this law. So that is why he hired those engineers with the designed balloon for him. This is the history, and nowadays it is being used like very commonly, very often. You can go and enjoy the hot air balloon ride. It is based on the principle that hot air occupies greater volume, right? The moment you increase the temperature, volume also increases, right? So what you do, that you take small quantity of the air, but you keep it hot, right? So there is always a lamp. I mean, if you go and take the ride, there is always a lamp which you have to keep ignited during the entire your journey so that the air remains. And there are special envelopes also to keep the air hot. So hydrogen gas, and also you have to choose the gas which is lighter, right? So it is because that hot air, if you heat the air, it is what? Less denser. How? Because the mass is fixed, right? How do you define the density? Density is mass upon volume. Mass is fixed. You cannot change mass here. Mass is fixed. So for a fixed amount of mass, you increase the temperature. Increase the temperature, volume also increases. So same amount of gas is occupying now greater volume, right? So hot air is occupying. Now what happens? That its density is inversely proportional to volume. It is less denser. So the hot air compared to the cold air is less denser. When it is less denser, you know that, I mean, obviously it will rise, right? So, and also, I mean, though it is not related here, but I would still discuss that it has some relation to the buoyancy. Are you aware? You must have learned the concept of buoyant force in physics, right? So it is that principle says that the amount of the mass displaced by that object, if it is greater, it will float. If it is lesser, it will sink. On the same principle, you say that the ship is always on the ship will float, and wherever if you have smaller object, they will sink, right? So hot air, less denser goes up in the air, and more dense air remains in the air. So hot air balloons, they are the very good examples of your Charles law. You can also relate, density, if you in any numerical, not only that in if in numerical, instead of volume, I asked you to calculate the density, you must be able to relate it to the density, right? Or provided you know the relation between the different quantities, you can calculate any one. Next. Yes, I wanted to discuss this thing with you, that when I discussed the statement of Charles' law, I said that volume is directly proportional to absolute temperature. Absolute temperature, by absolute temperature, I mean that, yes, I mean, see, if you take the temperature also in degrees Celsius, it is not, the relation is not. Actually, before giving this law, Charles observed the behavior of gases, that what happens if you increase the temperature. So what he observed, that if you increase the temperature by 1 degree Celsius, right, what happens to the volume? Volume increases by 1 upon 273.15 times the original volume. Say the volume at 0 degree Celsius is V0, and now at any other temperature T degree Celsius it is Vt. So what is the relation between the two? I've written it here, that Vt will be equal to V0 plus T upon, means T, why here we have written T? It is because T is number of degrees Celsius by which you increase. It is the temperature by which you increase the sample, and it will follow this relationship. Now, this relationship is very, very important, because otherwise, if you do not write the absolute temperature, then what happens? What do you suspect the case should be? Then V is directly proportional to T. The moment you make the temperature 0, volume should also become 0. But do you observe that? Volume at 0 degrees Celsius, volume of a gas, will it become 0? No, it will not. So before that, actually, before the volume of a gas turns to 0, it is a hypothetical concept. That is what I want to explain you here. It is from this law that the concept of a new scale of temperature called Kelvin scale came into role, that before it becomes 0, which we predict, but the gases, they liquefy. If we do not write here the absolute temperature, then at T is equals to 0 degrees Celsius, volume should also be 0. But it is not so. Before the volume turns to 0, the gases, they start liquefying, because you know that if you keep on compressing the gases, the molecules of the gas, they come closer to each other. You have less spaces. So by decreasing the temperature, when they come close to each other, the physical state of a gas changes into a liquid, right? So when they turn to a liquid, you know that liquids are not highly compressible. You cannot compress the liquid to a greater extent, right? So they are not compressible. But when we extend this, you can see from here also in this picture, if we, using the concept, if we keep on extrapolating this, so this is the volume of a gas that which it occupies at 0 degrees Celsius. So it is not 0, the intercept, you see, right? So intercept is not 0, it means volume at 0 degrees Celsius is not 0. When does a volume of a gas becomes equal to 0? You put in this equation. You see that when the temperature is what? Minus 273 point. In this expression, if you substitute T is equals to minus 273.15, then this will become what? 0. So it is called absolute 0 at the temperature scale. Minus 273.1, specifically 0.15 degrees Celsius is called absolute temperature, and it is completely a hypothetical concept, because one, this temperature is almost next to impossible to attain. This much negative temperature you cannot attain. And the second thing, that, I mean, if we could somehow attain this temperature, then gases would occupy 0 volume. But it is not so when we observe the behavior of real gases, because they turn into a liquid before this stage occurs, right? So here we define a new scale, that volume is directly proportional to temperature, but it is not the temperature in degrees Celsius, it is the temperature in Kelvin. Next. You can perform a simple experiment. You try at your home also, that if at higher temperature, I mean, you have a simple balloon which is being filled with air, right? So this is there. If you want to see the relationship between volume and temperature, you pour some chilled water on it, lower the temperature, volume will also decrease, right? Next, I have again some problems based on Charles' law, right? So again, this is there, a sample of argon gas, original volume is 14.6 liter at 25 degree Celsius, and it is heated to, so temperature here is being doubled, right? So you double the temperature, and what is its new volume? You know that you can use a simple mathematical relation, but one thing you have to keep in mind, that you will have to convert the temperature to the Kelvin scale. The moment you will have to use this relation, V1 upon T1 is equals to V2 upon T2 is equals to V3 upon T3, and so on, you will have to have the temperature in Kelvin. You cannot have the temperature in the degree Celsius. In fact, then the Kelvin scale was used as a Kelvin, you know that it is your SI unit of temperature also. Next, just a small deviation from, I mean, not deviation actually, but the two are very much interrelated. Actually, Charles and Gay-Lussac, they were co-workers. They worked together. So during their work, the two are responsible for inventing the hot air balloon technology also. And simple thing, and you see that if you keep the volume constant instead of pressure, now you keep the volume constant, right? You keep the volume constant and see the variation of pressure with temperature. And what do you observe? You observe that pressure is directly proportional to temperature. You increase the temperature, pressure also increases, right? The similar kind of curves you can get here also, that you have pressure here, temperature here, the two are directly proportional to each other. See, you are getting different curves. So what are the curves called? Curves at four different volumes, V1, V2, V3 and V4. These are four fixed volumes, right? So these curves are known as iso curves or lines. They are known as isochores. The curves which we plot at constant temperature are called isotherms, right? Isotherms at constant temperature, isobars at constant pressure, isochores at constant volume, right? So all these, when we take the different volumes, you get a relationship which is being given by one line, but since you have changed the volume also, so you get different, and the relationship simple, just like volume and temperature relationship, you get P1 upon T1 is equal to P2 upon T2, and so on, is a constant quantity, right? Then next we have this law. Up till now we have taken a fixed quantity of gas, right? Till now we have restricted that we take a fixed mass of gas, we take fixed quantity of gas. Now here also we see that if you keep the temperature and pressure constant, both the quantities, up till now we were keeping one of the three variables, pressure, temperature and volume, one of these as constant and also mass as constant. Now we have to change that thing, right? So you keep the temperature and pressure constant. Keep the temperature and pressure constant, then you will observe that volume of a sample of gas is directly proportional to its number of moles, right? It means volume indirectly. What is the application of this also? That you must have heard that all gases at STP, they occupy same volume, right? 22.4, somewhere it is quoted 22.7 liters. So it is the consequence of your Avogadro's law only, that because it says that volume is directly proportional to the number of moles. It is not related to the characteristic properties of the gases. It means whether you take the hydrogen gas, you take the oxygen gas, you take carbon dioxide, you take ammonia, any gas, all the gases will have, if they have equal volume, they will have equal number of moles, or reverse. If you take equal number of moles, then they will occupy the equal volume, right? So volume is directly proportional to number of moles. We can also see from here, this example, you see 3 molecules of hydrogen and 1 molecule of nitrogen combines to give us 2 molecules of ammonia, right? So if you take this, I mean, you take these two differently, mix them, they will also have the same volume. This will also have the same volume. So volume, whether you take of any gas, it is not, and you know that it is number of moles. So you must be able to understand, I mean, you must have learned mole concept. So 1 mole of any gas contains how many molecules? 6.03 into 10 raised to power 23. That is Avogadro's number. So those many molecules are there in a gas. So all the gases, a consequence of Avogadro's law, that all the gases at STP, they occupy the same volume. Now next is again we have a numerical problem based on this. If you combine 3 liters of NO, I mean, and then 1.5 liter of O2, then they, I mean, the balanced equation is written here, right? Then what volume of nitrogen dioxide will be produced? Just now I gave you the concept. All are at this, you have to assume that, and when they follow Avogadro's law, you have to keep temperature and pressure constant. Now you have to use this concept. See, because volume is proportional to number of moles, right? So in the balanced equation, the stoichiometric coefficients, right? I hope you understand stoichiometric coefficients. These coefficients, 2 and 1 here and 2 here, they indicate that the number of moles which are reacting together in order to make NO2. So their volumes would also be, because volume is directly proportional to what? Number of moles. Since the number of moles which are being reacted, they are being indicated in this chemical equation, right? So you can also say that their volumes would also be in this ratio, right? So you see here, 2 moles of NO gives you how many moles of NO2? 2 moles of NO2. So what volume of NO2? Same volume of. Whatever volume of NO you will use, you will get same volume of NO2, right? The amount of reactants. So this plus this. Sorry, 2 moles of this and 1 mole of this will give you this. So 2 plus 1, 3 moles of NO2, 3 volumes of NO2, right? Next. Again, example, numerical. We will discuss if we have more time afterwards. Let us now discuss the next concept.